Hello, and welcome. My name is Andrew, and today I'll be explaining a little bit about the Galileo spacecraft. First, I'm going to give you a brief overview of Galileo's mission, then I'll go into some detail about its design and configuration. Now, Galileo was designed to go to the Jovian system and study as many things as possible about the planet and its moons. And that's exactly what it did. For about 8 years, Galileo studied the magnetic fields, the atmosphere, charged particles, the geography of the Jupiter's moons, and eventually it was deorbited and purposefully smashed into Jupiter. So, the Galileo spacecraft had a pretty unique design. Orbiters before it, like Voyager and Pioneer, had been designed one of two ways. Either they would spin about a single axis, or their orientation would be stationary, and they would be stabilized by small thrusters. Galileo was special because it combined both of these aspects. It was divided into two parts, the top half, called the spun section, and the bottom half, called the despun section. Alright. I'm going to talk now about some of the components that make up Galileo. Let's start with the power source, because, well, satellites would be pretty useless without them. Galileo used two radioisotope thermoelectric generators, or RTGs for short. These were pretty common on deep space satellites such as Galileo. They used the decaying of radioactive materials to generate a heat differential across a thermocouple. This thermocouple then makes use of the Seebeck effect to generate electricity. Now, because the RTGs emit relatively high amounts of radiation, they have to be shielded from the rest of the satellite so they don't interfere with the sensitive scientific equipment. And you can see the way these shields are deployed on the RTG booms. They're the thin sheets of metal that block the radiation from hitting the main body of the satellite. The RTGs used on Galileo could generate about 500 watts, which is enough to light up 8 traditional incandescent light bulbs. Moving on, we've got two groups of thrusters, which could provide about 10 newtons of thrust each. We also have the main thruster, which could operate at 400 newtons of thrust. And finally, the retropropulsion module, or RPM, which was responsible for linking the thrusters to the computer so they could receive commands detailing the duration, strength, and direction of their burn. Here we've got the high gain antenna, or HGA, and the low gain antenna, or LGA. Unfortunately, the high gain antenna failed to deploy on Galileo, so the controllers were forced to use the less powerful low gain antenna for almost all of their communication. Alright guys, it looks like that's all the time we've got for this video, but you can check out the paper if you'd like to learn more about Galileo.